Well, the position of an object that is free falling due to gravity is, cue the Tom Petty song, we have negative a over 2 t squared plus v sub 0 t plus s sub 0. We can call it v naught and s naught. And that is just a good way of saying that's where we start. So let's actually do this. This is the initial position above the ground. And this is going to be the initial velocity, which makes sense actually. Initial position would be if 0 time has elapsed, that would be where you are. So if I plugged a 0 here and a 0 here, I would be here. If I took the derivative of this, then s sub 0 would go away, and I would have v sub 0, I would have v naught, and that would be my initial velocity because that would be, well, the derivative would be velocity, and then in the process of doing that, v naught would be the only term left. Plugging in a 0 for t would give me that, just that. Anyway, enough of that. A is the gravitational constant on Earth. We are not going to be falling on the moon. And it is due to gravity, and it is equal to negative 32.2 feet per second per second. Now, I've got the negative built in here, so we're just going to go with 32.2. And also, it's the same thing as 9.81 meters per second squared. Okay, so this is the gravitational constant on Earth. That's A. You do not have to memorize these numbers. It's just good to know for physics. And so let's just jump right in. Jump right in, get it? At time t equals 0, a diver jumps from a diving board that is 32 feet above the water. Let's just stop right there and jump ahead. Jump. Man, that joke just keeps getting better. This is the position of the diver. And he jumps from a diving board that is 32 feet above the water. His initial position is 32. See, notice that, 32. Because the initial velocity of the diver is 16 feet per second, notice that is positive, which means the diver is jumping up and then he's going to come back down. Then the position of the diver is negative 16t squared plus 16t plus 32. Notice this negative 16t squared. It is not this 16. This 16 is this 16. This is the initial velocity, upward velocity. And so if you're picturing this, there's this, there's a diver. There he is. There's a swimming pool. See that blue water right there? And there is a diver that is 32 feet above the water. There we go. And this distance right here is 32, and there's your diver. You know I'm not a very good drawer. He has no head. There we go. And so this person is going to jump up and then come back down. All right. Here, let's make things interesting for this diver. All right, anyway, moving along. S is measured in feet and T is measured in seconds. All right, let's zoom in just a little bit here so we can get to work on this a little bit closer. Let's see. Oh, by the way, this negative 16t squared, it comes from that. So the negative a over 2, they rounded this one. So it was negative 32 over 2, so negative 16. At what time t does the diver hit the water? Well, this is going to be relatively straightforward. So not straightforward in his motion. Well, it kind of is. He goes up and then down. So what time t does the diver hit the water? Well, when the diver hits the water, he is at position 0. So S of t equals 0, which is negative 16t squared plus 16t plus 32. And we are going to solve this, and we can do this by hand. So let's factor a negative 16 out of this. So t squared minus 1t minus 2. And we'll have 0 equals negative 16, and then t and minus 2, and then t plus 1. So we're going to have a couple t values. One of them is feasible, the other one is not. Positive 2 seconds and negative 1 seconds. Well, negative 1 seconds doesn't make sense unless you're a time traveler, and this diver is not. I think it's safe to assume that this diver is not a time traveler. So what we are going to do, I'm really concerned for this diver. You can see why. I'll put piranhas down here too. this -1 is just an extension of like going backwards in time of following the path, and then the diver like falls off, and then the shark. Anyway, toss that one out. Negative time is not valid yet. But it will be yesterday. Oh man, I love that joke. Okay, so final answer is 2 seconds. It takes 2 seconds for this diver to hit the water. Well, what's the diver's instantaneous velocity and impact? Well, the velocity is going to be the derivative of the displacement. So I need to show that. I need to show that I have the derivative of displacement, which is the velocity, and that would be -32 t. See, notice it pops back up. Right there it is. There it is. And I lost my place. Oh, plus 16. So initial velocity is 16. Makes sense. But I want to know the instantaneous velocity. That is the velocity at that moment. So the velocity at 2. Now that we have defined v as the derivative of s, I'm able to just keep going with v. But don't leave that part off. Don't be like, well, the velocity is this, because the people that grade free response need to know that you have made this connection here. Okay, so -32. Let's fix that. -32 times 2 plus 16, and that's going to give me -48. But I want to include units, and units in this case would be, well, the velocity, and this is measured in feet per second. And then at what time t is the diver at rest? Now, let's be really specific with this. The diver is in motion from the time he jumps off the board to the time he lands in the water, and then things get really crazy. See? Fun stuff. But when I say at what time t is the diver at rest, this goes back to some of the things that you have heard initially, and that is where the velocity is equal to 0. So the diver goes up and then comes back down. And for an infinitely small fraction of a second, the diver is floating midair. So -32t plus 16. And we will solve that. And let's just not work through all this. Subtract 16 divided by -32. And I'm going to have 1/2. And it is 1/2 second after jumping off the platform. Is the diver speeding up or slowing down at t equals 0.25? Oh, okay. Now we get to some fun stuff. So I want to know if the diver speeds up or slows down at a specific time. And that is best done by plugging in a number into the velocity function. We'll figure that out. And also plugging a number into the acceleration function, which we haven't found yet. So the derivative of velocity. Oops, let's not do that yet. Let's not plug in 0.25 yet. Let's go ahead and define the acceleration function as the derivative of velocity. And that's going to give me just simply -32. And so to be clear on this, if I was to extend this even further, I'd say, well, the acceleration at 0.25 is -32. It doesn't matter what I pick, it's going to be negative. And so that, of course, is less than 0. All right, my purple pen is acting up again. So let's plug in 0.25 into the velocity function. We can do this one in our head. So -32 times 0.25 plus, come on, pen, come on. There we go. See, it works. Just got to coax it a little bit. So -32 times 1/4, that'd be -8. -8 plus 16 is +8, and that is, of course, positive. So here's what we're dealing with. When I'm asked about if something is speeding up or slowing down, I need to compare the signs of velocity and acceleration. And so I have a positive velocity but a negative acceleration, and therefore the diver is slowing down. And it's a good idea to explain what, explain why. They didn't ask you to, but I'm going to. The diver is slowing down at t equals 0.25 seconds. Come on, ink pen. Because, I need to finish the sentence and you got to work, ink pen. Because the velocity is positive and the acceleration at that same time, the acceleration at any given time is negative. Okay, they have different signs. Okay, what is the average velocity of the diver on the interval from 0 to 1? So we might be tempted to find the slope of velocity. No, we are going to find the slope between 2 points of displacement, and the units will work out to be velocity. Okay, this is going to be fun. Average velocity. I'm going to switch ink pens for a minute. Give the purple one a rest. Let's switch to blue. I want to know the slope between, and I'm going to write that down. I'm just writing down some thoughts. I want to find the slope on the line that would connect, the secant line, if you will. Find the slope that would connect 0, s of 0, and 1, s of 1. And we're going to figure that out. In doing so, the units work out to be that represents velocity. So s of 1 minus s of 0 over 1 minus 0. The numerator is going to be feet. The denominator is going to be seconds. That's going to give us feet per second. So plugging in a 1 into the position function, plug a 1 right here. We'd have negative 16 plus 16. And that cancels out. We have 32. Lucky us. 32. Plug in a 0, we'd get 32. Whoops, not 30, it's 32. And obviously we're dividing by 1. So we really have 0 feet per second. So at 1 second, the diver, this is the explanation, at 1 second, the diver is at his starting point, the initial height. I'm going to write that down. So at t equals 1 second, the diver is at his starting point. Okay, let's explain this with a picture. This explanation is perfectly fine, but the diver is 32 feet from the pool. Well, the diver started 32 feet from the pool. So in the interval from 0 to 1, the diver went up and then down. Okay, so the diver jumps up, the diver comes down. This is 0 seconds. This is 1 second. Well, what's the slope between these 2 points? All right, and that's kind of a bad representation because this is not necessarily the path. This is the height. But the slope that connects any point that has the same value is going to be 0, right? So again, let's not get too caught up in, oh, what's the path of this? And it looks like a parabola. That's not the point of this. But jumped up from 32 feet, and at a specific moment, it's 32 feet. So if I was to just say, how far has this guy traveled? Well, at that moment, it would look like he hasn't traveled at all, other than the fact that he's floating in midair. But it would look like he hasn't traveled at all, which is why the velocity, average velocity, is 0. Okay, now we have a series of 3 questions that are going to give us some very interesting and curious things. So let's deal with that. What is the average acceleration of the diver from 0 to 1, from 0 to 2, and from A to B? Wait, what? Now I have to just plug in A's and B's? Okay, well, I'm not going to be plugging things into the acceleration function. I'm going to be plugging things into the velocity function. So again, we're going to find the slope. Whoops, wrong color. Let's find the slope. You never know there was a red pen there. Find the slope between 0 v of 0 and 1 v of 1. And when I do so, the units will work out to be that represents acceleration. And we're going to do the same thing here. We're going to find the slope between 0 v of 0 and 2 v of 2. And then we're going to find the slope between A v of A and B v of B. Okay, same thing. So here are units, our points. This and this. And here, our points are A, V of A, and B, V of B. Okay, so let's keep going. V of 1 minus V of 0 over 1 minus 0. Let's see, if I plug the 1 into the velocity function, I would get negative 16, trust me, but you can look at it yourself. If I plug a 0 in, I would get negative 16. And that gives me a 1 there. So that gives me negative 32 feet per second per second. Okay, so this unit, the units up here were feet per second, and then I divide by second. So it's feet per second per second. So feet per second squared. Let's do the same thing here. So V of 2 minus v of 0, and that's going to give me 2 minus 0 in the denominator. So 2 in the denominator, that one's obvious. V of 2 is negative 48. This is 16. We figured that out already. And I have negative 64 over 2, which is negative 32 feet per second per second. So the average acceleration is the same on this interval as it is on this interval. I wonder if it's always the same. And that's what we're about to find out just by using arbitrary variables like a and b. So what's the average acceleration of the diver on the interval from a to b? Well, let's find out. V of b minus v of a over b minus a. I wonder how this is going to work out. We're going to have some variables to contend with. If I plugged a v into a b into the velocity function, I would have negative 32b plus 16. And then I'm going to subtract away what I'd get when I put a into the velocity function, and that would be negative 32a, so plus 32a, and then plus 16, but I'm subtracting the whole thing, so there was that, all over b minus a, and we'll see what we get. Let's see, let's keep going. The 16s are going to cancel, 16 minus 16, and I have negative 32b plus 32a over b minus a, and I can factor out a negative 32 in the numerator, and it gives me this over this. Oh my goodness, you see it, don't you? I have negative 32, negative 32 feet per second. There it is, I'm running out of space. Oh no, it's getting kind of sloppy. But negative 32 feet per second, regardless of which 2 points I pick, because that is the acceleration. Because we're on Earth. There you go.